Design for testability. Design for testability or DFT refers to those design techniques that make test generation and test application cost-effective. DFT methods for digital circuits are ad hoc methods, then structured methods. The pointer scan, partial scan, built-in self-test, and boundary scan. For DFT method for mixed signal circuits, the point is analog test bus. Controllability and observability. The key to design for testability is the ability to control and observe directly the internal states. Controllability of an internal node, ability to set it to a specific logic value. Observability of an internal node, ability to observe its specific logic value on primary output. Ad hoc DFT. There are two forms of DFT: ad hoc and structured. Ad hoc DFT useful for small design where scans, BIST are not available. Use bus-oriented purpose for test. Each register made loadable from the bus and capable to drive onto the bus. Internal logic values that exists on data bus are enabled for testing purpose. Ad hoc DFT relies on good design practices. It avoids asynchronous logic feedbacks. Feedback can result in oscillation. Test pattern generator are designed to work on acyclic combinational logic. Make flip-flops initializable, in the other word, it provide clear and reset pin control. Ad hoc DFT avoid gates with a large fan-in. Large fan-in makes the inputs difficult to observe and the output difficult to control. Provide test control for difficult to control signals. For example, signals produced by a long counter require many clock cycles to control. This increases the length of the test sequence. Ad hoc DFT design reviews conducted by experts or design auditing tools. The disadvantages of ad hoc DFT method are: experts and tools not always available. Test generation is often manual with no guarantee of high fault coverage. And design iterations may be necessary. Structured DFT. Structured DFT involves adding extra logic and signals dedicated for test according to some procedure. The most commonly used structured methods are scan and BIST. During design stage, if scan DFT is selected to be implemented as test method, multiplexer is inserted at the input data D of the flip-flop block. This design called multiplexer D scan cells. For scan DFT, the circuit has two modes, normal and scan mode. For normal mode, flip-flops behave as usual. It means, during normal application, data is received from input pin D and stored in the flip-flop before it goes to combinational logic gates as normal operations. For scan mode, flip-flops behave as shift register. Only applicable during test. For example in production or test labs. End users usually not able to set scan mode. Data input is selected from SI pin. Scan cells will connect to become scan chains. Data inside flip-flop will be transferred out through the scan chains to primary output pin for failure analysis purposes.
Created using PowToon.